Welcome back, fellow space enthusiasts, to our cosmic journey through the Messier catalog. In this episode, we're strapping on our metaphorical spacesuits and venturing deeper into the universe, exploring a new set of celestial wonders. Today, we'll be setting our coordinates for Messier Objects 67 through 88. From the dazzling beauty of open clusters to the enigmatic allure of globular clusters and the awe-inspiring grandeur of galaxies, we'll be covering a cosmic tapestry of astronomical objects. So, whether you're a seasoned astronomer or a stargazing novice, prepare to have your mind boggled by the sheer scale and wonder of the cosmos. Buckle up because we're about to embark on an unforgettable journey through the cosmos, exploring the universe one Messier object at a time. Let's get started. Our first stop brings us to the constellation of Cancer, where we encounter Messier 67, or M67 for short. Now, unlike some of the densely packed globular clusters we've encountered, M67 is an open cluster, a loose collection of stars born from the same giant molecular cloud. Imagine a cosmic nursery, if you will, where hundreds of stars, all roughly the same age, sparkle like diamonds scattered on black velvet. Located about 2,900 light-years away, M67 is of particular interest to astronomers because it's one of the oldest known open clusters, with an estimated age of about 4 billion years. That's ancient in astronomical terms, especially when you consider that most open clusters disperse after a few 100 million years, torn apart by the gravitational tug-of-war within our galaxy. Yet M67 persists, a testament to the enduring forces that bind these stellar siblings together. Studying M67 gives us a unique window into stellar evolution, allowing us to observe how stars of different masses age and evolve in a relatively isolated environment. It's like having a cosmic time capsule, offering glimpses into the life cycle of stars and the ever-changing dynamics of our universe. Next up, we shift our gaze to the constellation Hydra, home to Messier 68, a dazzling globular cluster with a story to tell. Now, picture this: a sphere of stars, hundreds of thousands strong, bound together by their mutual gravity, orbiting a galactic core like a swarm of bees around a hive. That's M68, a celestial snow globe located about 33,000 light-years from Earth. And just like snowflakes in a globe, each star in M68 is unique, with its own story to tell, its own journey through the vast expanse of time and space. But here's the thing about globular clusters like M68. They're not just beautiful to look at, they're also cosmic laboratories that allow us to test our understanding of gravity, stellar evolution, and the very structure of our galaxy. By studying the motions of stars within these dense clusters, we can learn about the distribution of dark matter, that invisible substance that makes up the majority of the universe's mass. It's like piecing together a cosmic puzzle, using the faint light from distant stars to unravel the mysteries of the universe. Okay, cosmic explorers, in our ongoing quest to unravel the mysteries of the Messier catalog, we arrive at Messier 69, a celestial treasure tucked away in the constellation Sagittarius. Now, when we talk about globular clusters, we're talking about ancient stellar neighborhoods. Messier 69, or M69 for short, is a perfect example. Imagine a cosmic beehive, teeming with thousands, even hundreds of thousands of stars, all bound together by their mutual gravitational pull. They're packed so tightly, these stars, that the average distance between them is less than a light-year. Here on Earth, our nearest stellar neighbor, Proxima Centauri, is over 4 light-years away. Located roughly 29,700 light-years from us, M69 is a relatively small globular cluster, spanning a mere 50 light-years across. But don't let its size fool you. This cluster is estimated to be over 12 billion years old, making it one of the oldest inhabitants of our Milky Way galaxy. You see, studying these ancient relics allows us to peer back in time to understand the conditions present during the early universe. They offer clues about the formation and evolution of galaxies, and maybe, just maybe, they hold secrets to the very building blocks of the cosmos itself. Our journey through the cosmos takes us now to another breathtaking globular cluster in Sagittarius Messier 70, or M70 as it's more commonly known. Now, if some of these globular clusters seem similar, it's because they are. You see, The universe has a habit of repeating itself, especially when it comes to the laws of physics and gravity. M70 is remarkably similar to M69 in size and age. It, too, is a tightly bound ball of stars, spanning roughly 68 light-years across and situated about 29,300 light-years away from our pale blue dot. But don't mistake similarity for lack of intrigue. M70 holds a special place in astronomical history. Our cosmic voyage brings us now to Messier 71, or M71, a fascinating object nestled within the constellation Sagitta, the Arrow. Now, unlike the previous two tightly packed globular clusters, M71 stands out as a bit of an enigma. For centuries, astronomers debated its true nature, wavering between classifying it as a loosely packed globular cluster or an unusually dense open cluster. You see, open clusters, unlike their globular counterparts, are relatively young stellar groupings, often found within the spiral arms of galaxies like our own Milky Way. They're less tightly bound by gravity and tend to disperse over time. Globular clusters, however, are the universe's senior citizens, ancient relics of the early universe. M71's stars are more spread out than those of a typical globular cluster, and its chemical composition hints at a younger age than its globular brethren. However, recent studies have tipped the scales in favor of M71 being a rather loosely concentrated globular cluster, albeit one with a youthful spirit. Located around 13,000 light-years from Earth, M71 provides a unique opportunity to study the dynamics of stellar evolution in a less densely populated environment. It's a reminder that the universe rarely fits neatly into our preconceived notions, and there's always more to learn and discover. Messier 72, or M72 as it's called, is a globular cluster hanging out in the constellation Aquarius. Now, when I say hanging out, I mean it's about 55,000 light-years away from us, which in cosmic terms is like your friend who moved to the suburbs. Not too far, but you don't see them every day. This cluster is a tightly packed sphere of stars, bound together by their mutual gravitational attraction. Imagine a cosmic dance party where the stars are so close, they're practically stepping on each other's toes. And this party has been going on for billions of years. M72 is one of the more faint globular clusters in Messier's catalog, but don't let that fool you. It's still a sight to behold. Through a decent telescope, it appears as a fuzzy patch of light. But with larger telescopes, you can resolve individual stars like glimmers in a distant cityscape. So next time you're gazing up at the night sky, remember M72, a cosmic dance party that's been raging for eons. It's a testament to the enduring power of gravity and the sheer scale of the universe we inhabit. Messier 73, or M73. This one's a bit of a head-scratcher, even for an amateur cosmic explorer like myself. You see, M73 is what we call an asterism, which is basically a group of stars that appear close together in the sky, but aren't actually physically related. Think of it like a cosmic game of connect the dots. Our brains are hardwired to find patterns, so we look up at the sky and see shapes and figures where there are none. M73 is a perfect example of this. For centuries, astronomers thought M73 might be a loose open cluster, a group of stars born from the same cloud of gas and dust. But observations with modern telescopes have revealed that these stars are at wildly different distances from us, meaning they're not actually bound together by gravity. So, what are we to make of M73? Is it a true deep sky object or simply a figment of our imagination? Perhaps it's both. After all, the universe is full of mysteries, and sometimes the greatest discoveries come from questioning what we think we know. Messier 74, or M74 for those in the know, is a real showstopper. It's a spiral galaxy, much like our own Milky Way, located about 32 million light-years away in the constellation Pisces. Now, you might be wondering, why are spiral galaxies so darn interesting? Well, buckle up, because we're about to take a cosmic joyride. First off, M74 is what we call a grand design spiral galaxy, meaning its spiral arms are incredibly well-defined and prominent. Imagine a cosmic pinwheel, its arms swirling outwards in a mesmerizing display of celestial mechanics. It's a sight that makes you appreciate the sheer elegance of the universe. But M74 is more than just a pretty face. It's also a hotbed of star formation. Those spiral arms you see are like cosmic nurseries where giant clouds of gas and dust collapse under their own gravity, igniting new stars into existence. It's a process that's been happening for billions of years, and it's what gives spiral galaxies their characteristic blue hue. So next time you're looking up at the night sky, remember M74, a galaxy where stars are born, gravity dances, and the universe puts on a show for anyone with a telescope and a sense of wonder. Messier 75, or M75, is a stellar metropolis located 67,500 light-years away in Sagittarius. It's a dense ball of 400,000 stars bound by gravity. Imagine a single point of light that's actually hundreds of thousands of stars. M75 is a Class 1 globular cluster, one of the most densely concentrated in our galaxy. If you were on a planet within M75, the night sky would be ablaze with starlight. It's a cosmic dance of stars moving under each other's gravitational influence. M75 is ancient, nearly 13 billion years old. Studying these clusters gives us a glimpse into the early universe. It's like looking back in time, witnessing the universe in its infancy. So the next time you spot M75, remember, it's a relic of the early universe. From globular clusters, we shift our gaze to something a bit more ephemeral. Messier 76, the Little Dumbbell Nebula, is a planetary nebula about 2,500 light-years away in Perseus. These cosmic butterflies are remnants of dying stars, like our sun. When a star runs out of fuel, it sheds its outer layers, creating glowing clouds of gas and dust. M76, with its double-lobed structure, is a spectacular example of this process. The vibrant colors tell us about the nebula's chemical composition. By analyzing these colors, we gain insights into stellar evolution. M76 is the final act of a star, a cosmic swan song. But it's also a story of rebirth. The ejected material will seed new stars and planets, continuing cosmic evolution. All right, buckle up, space explorers. We're exploring Messier 77, a barred spiral galaxy in Cetus, about 47 million light-years away. It's an active galaxy, one of the closest and brightest. At its core is a supermassive black hole, millions of times the mass of our sun. Gas and dust spiral in, releasing energy across the spectrum. The active galactic nucleus shines brightly, outshining stars. M77 is a nearby laboratory for studying these phenomena. But there's more to M77 than its active core. It's a swirling disk of stars, gas, and dust with star-forming regions. Black holes exist in tandem with their galaxies, influencing each other. Messier 78, or M78 as it's often called, is a fine example of what we astronomers call a reflection nebula. Now, unlike emission nebulae, which glow with their own light due to the ionization of gases, reflection nebulae shine with borrowed light. Think of it like this. Imagine a streetlight on a foggy night. You don't see the fog itself glowing, do you? No, you see the light from the streetlight scattering off the tiny water droplets in the fog. That's essentially what's happening in M78. You see, M78 is a cloud of interstellar dust and gas, and embedded within it are some hot, young, blue stars. These stars emit a tremendous amount of ultraviolet radiation, and it's this radiation that bounces off the dust particles in the nebula, causing it to shine. And because blue light scatters more efficiently than other colors, the same reason our sky is blue, M78 takes on a beautiful, distinct bluish hue. It's a cosmic mirror, reflecting the brilliance of the stars it cradles. Now let's journey to Messier 79, or M79, another cosmic treasure trove located about 42,000 light-years away in the constellation Lepus. Now, unlike M78, which showcased the birth of stars, M79 takes us to the other end of the stellar life cycle. See, M79 is what we call a globular cluster. Imagine a giant cosmic snow globe, chock full of hundreds of thousands of stars, all huddled together by their mutual gravity. These stars, my friends, are old, some of the oldest in our Milky Way galaxy, clocking in at around 11.7 billion years old. That means they were around when the Milky Way itself was just a baby galaxy. Studying these ancient stellar populations allows us to piece together the history of our galaxy, like looking at an old family photo album. We can analyze their chemical composition, their movements, and their interactions to understand the conditions present in the early universe. Globular clusters like M79 are like time capsules, offering glimpses into the distant past. Our next stop takes us to the constellation Scorpius, home to Messier 80, yet another spectacular globular cluster in our cosmic neighborhood. Located about 32,600 light-years away, M80 is a sight to behold, even through a modest telescope. Now remember those densely packed stellar cities I mentioned earlier? Well, M80 takes it to another level. It's one of the densest globular clusters in the Milky Way, with hundreds of thousands of stars crammed into a relatively small volume of space. Imagine living on a planet in the core of M80. The night sky would be ablaze with the light of countless stars, so close you could almost reach out and touch them. Talk about a stargazer's paradise. But this density also leads to some interesting stellar interactions. Stars are constantly jostling for position, sometimes even colliding with each other. These collisions can trigger the formation of new stars or even more exotic objects like blue stragglers, which appear younger and bluer than they should be given their age. M80 is a cosmic melting pot, a testament to the dynamic and ever-evolving nature of our universe. In our ongoing quest to unravel the mysteries of the Messier objects, we arrive at number 81, more famously known as Bode's Galaxy. This magnificent spiral galaxy, located about 12 million light-years away in the constellation Ursa Major, offers a glimpse into the grand design of our universe. Now, when we talk about spiral galaxies, we're talking about cosmic structures so vast, so awe-inspiring, that they make our own Milky Way galaxy seem like a mere speck of dust. And Bode's Galaxy is a textbook example, with its well-defined spiral arms glittering with the light of billions of stars. Those spiral arms, my friends, aren't just pretty to look at. They are cosmic nurseries teeming with gas and dust, the raw materials for star formation. It's like looking at a cosmic fireworks display frozen in time, with each spark representing the birth of a star. But Bode's Galaxy isn't alone in its corner of the cosmos. It's gravitationally bound to its galactic neighbor, Messier 82, forming a dynamic duo that's locked in a cosmic dance. And as we'll see in the next chapter, this interaction has had a profound effect on both galaxies. From the graceful swirls of Bode's Galaxy, we turn our attention to its cosmic dance partner, Messier 82, also known as the Cigar Galaxy. Now, this isn't your average run-of-the-mill spiral galaxy. Oh no, M82 is a starburst galaxy, a cosmic cauldron where stars are forming at a furious rate. You see, the gravitational tug-of-war between M82 and its neighbor, Bode's Galaxy, has triggered a frenzy of star formation. Imagine a cosmic game of tug-of-war, but instead of rope, it's gravity pulling on vast clouds of gas and dust. This gravitational interaction has compressed the gas and dust in M82, igniting a firestorm of star birth. In fact, stars are forming in M82 10 times faster than in our own Milky Way. This intense star formation is what gives M82 its distinctive cigar-like shape, as if it's been stretched and pulled by cosmic forces. And speaking of cosmic forces, the Cigar Galaxy is also home to some of the most powerful supernova explosions ever observed. These stellar explosions, marking the death throes of massive stars, release more energy in an instant than our sun will in its entire lifetime. It's a reminder that the universe is a dynamic, ever-changing place, full of wonder and destruction on a scale that's hard to fathom. Our cosmic journey takes us southward now, to the constellation Hydra, where we encounter Messier 83, a dazzling spiral galaxy often called the Southern Pinwheel Galaxy. And let me tell you, this celestial pinwheel is a sight to behold. Located about 15 million light-years away, M83 is a face-on spiral galaxy, meaning we see it in all its glory, like a cosmic Catherine wheel set ablaze with the light of billions of stars. Now, some galaxies, they like to keep their spiral arms tightly wound, but not M83. Oh no, this galaxy lets its spiral arms loose, sprawling out across the cosmos like a grand galactic waltz. And it's within those dusty spiral arms that we find stellar nurseries, regions of intense star formation that illuminate the galaxy like cosmic streetlights. It's a reminder that even in the vastness of space, creation is an ongoing process, with new stars igniting into existence as we speak. But M83 isn't just a pretty face, oh no, it's a hotbed of galactic activity. Astronomers have observed numerous supernovae in M83, those explosive death throes of massive stars that briefly outshine entire galaxies. So, as we gaze upon the Southern Pinwheel, we're reminded of the constant cycle of stellar birth and death that drives the evolution of galaxies like our own Milky Way. Messier 84, or M84 for short, is our next stop on this cosmic journey. Now, when you hear the term lenticular galaxy, don't let your eyes glaze over. We're not talking about some obscure lens-making convention in the cosmos. Imagine a galaxy that can't quite decide if it wants to be a spiral or elliptical. It's got the disk of a spiral, but without the grand sweeping arms. Instead, it's got this smooth, lens-like appearance, hence lenticular. It's like the universe is giving us a subtle lesson in galactic indecisiveness. But don't mistake M84's seeming ambiguity for a lack of intrigue. It's located in the heart of the Virgo cluster, a bustling metropolis of galaxies, and it harbors a supermassive black hole at its core. And when I say supermassive, I mean millions, perhaps even billions of times the mass of our sun. So, as we gaze upon this cosmic lens, let's remember that the universe rarely conforms to our neat and tidy categories. It's a place of wonder, surprise, and yes, even indecision. From one lenticular galaxy to another, we arrive at Messier 85. Like its neighbor M84, it resides in the bustling Virgo cluster, a region teeming with galactic activity. But M85 has a few tricks up its sleeve, cosmically speaking. For starters, it's one of the brightest galaxies in the Virgo cluster, shining with the light of over 400 billion suns. That's a lot of starlight, folks. And it gets even more interesting. Astronomers believe that M85 may be interacting with a nearby dwarf galaxy, NGC 4394. Now, galactic interactions are some of the most dramatic events in the universe. Imagine two galaxies, each containing billions of stars, locked in a gravitational dance. Stars get flung about, gas clouds collide, and new stars are born in a fiery spectacle. While the interaction between M85 and NGC 4394 is still under investigation, it highlights the dynamic nature of the universe. Galaxies are not static islands in space. They evolve and change over billions of years, often through dramatic interactions with their neighbors. Our final stop in this lenticular trilogy brings us to Messier 86, another resident of the action-packed Virgo cluster. Now, we've talked about galaxies with grand spiral arms, galaxies with smooth elliptical shapes, and even galaxies that seem caught in between. But M86 throws us another curveball. You see, most galaxies in the Virgo cluster are moving away from us, their light stretched or redshifted as the universe expands. But M86 is doing something peculiar. It's moving towards us. That's right, folks. Its light is blue shifted, indicating that it's on a collision course with our own Milky Way galaxy. Now, before you panic, let me assure you this cosmic fender bender won't be happening anytime soon. We're talking billions of years in the future, but it does highlight a fundamental truth about our universe. Everything is in motion. Galaxies are born, they evolve, they interact, and sometimes they even collide. It's a cosmic ballet of epic proportions, and we're just fortunate enough to be witnessing it. Messier 87, or M87, is a giant elliptical galaxy in Virgo. It's home to trillions of stars and spans 120,000 light-years. Our Milky Way is just 52,000 light-years across. M87's core houses a supermassive black hole. This black hole is billions of times more massive than our Sun. The Event Horizon Telescope captured its first image in 2019. This was a groundbreaking achievement. M87 also has a powerful jet of energetic particles. This jet extends thousands of light-years from its center. Powered by the black hole's gravity, it propels particles at nearly the speed of light. It's a cosmic particle accelerator. M87 showcases the raw power of a supermassive black hole. Our next stop is Messier 88, a stunning spiral galaxy in Virgo. Classified as a grand design spiral galaxy, its arms are prominent and well-defined. These arms are stellar nurseries, bustling with new stars. M88 moves at 2,000 kilometers per second. But don't worry, it's not on a collision course with the Milky Way. This high speed is due to the Virgo cluster's gravitational influence. Studying M88 offers insights into spiral galaxies and star formation. The universe is dynamic and ever-evolving, and we're fortunate to witness its wonders. Well, folks, we've reached the end of our journey through Messier Objects M67 to M88. From the swirling clouds of gas and dust to the fiery hearts of distant galaxies, we've witnessed the awe-inspiring beauty and mind-boggling scale of the cosmos. But our exploration of the universe is far from over. There are countless more celestial wonders waiting to be discovered, and I, for one, can't wait to unravel their secrets. Stay tuned for the final part of our Messier Objects series, where we'll delve into even more cosmic marvels. And as always, keep looking up, and never stop questioning the universe around us. Don't forget to like and subscribe for more cosmic adventures. Until next time.